Welcome everyone. In this lecture we will take a quick overview on the DC motors. So now let's start with this question. What are the DC motor facilities? So the first facility for our DC motors is that it has the largest starting torque. So between all of our motors, the DC motor have the largest starting torque, and for this reason we can use it in the rolling machines. So the rolling machines, which can make shapes for the cast iron or the steel, can use the DC machines to overcome the larger value of inertia using our larger value of starting torque. So the second thing is that it's used in steel factories. So in a steel factories application we can use the DC machine, and it's also used in train and metros applications. So in some trains and metros we can use the DC machine for running our train or running our metro. So the concept of this train working is that its input will be a diesel fuel, and this diesel fuel will be an input for the generator. So this generator inside the train will generate an AC power, and this AC power can be used here with a rectifier, or it's introduced to a rectifier, and this rectifier will convert the AC power to a DC power, and this DC power can be used to run our DC motors. So this DC motors can convert this electrical DC power to a mechanical power which used in running the trains or in some metros. And here the second facility of our DC motors is that it have a hard related maintenance operation. So its maintenance operation is very hard. So for this reason it has no longer been used in many applications, and instead of F we use other types of machine like the synchronous machine. So it have a highly corrosion of carbon brushes. So it's a very big disadvantage in the DC motors in that its carbon brushes have a highly corrosion. So the carbon brushes like this one, which used to convert the power to lead it inside the machine, like here in this figure. So we can find that the carbon brushes can connect the external DC power source to the commutator, and this commutator will lead the DC power to the internal structure of our DC machine. So these DC brushes can have a highly corrosion, and this is a very big disadvantage of our DC machines. And the third facility of our DC motors is that its speed can be controlled easily, and this is an advantage of our DC motors. So its speed can be controlled easily with easy and popular method like the pulse width modulation method. And we can illustrate with this figure, in the large power electronics it will be more complex, but here this is only for illustration, and this circuit can be used for low power motors or low power DC motors, as we can connect our motor to a transistor here, and this transistor or the base of this transistor will be applied to some pulses, and these some pulses can reduce the input voltage. So suppose that this is our zero level of our input voltage, and this is the total voltage or the maximum voltage. So when we apply the input power at its total voltage for the time t on, and when we apply at zero voltage at t off, so we will find that the average power will be the total power, which is this value here times the t on over the t total. So this t on is the time at which we have a total value of voltage, and this here or this t on is the time at which we can apply a total here value of voltage, and this t total is the time at which we can apply the total signal. So the t total here equal the t off added to the t on. So the addition of the t on and t off will give us the t total. So we will find that at this condition the average input voltage is lower than the total voltage, and as the voltage is directly proportional to the speed, so we will find that when the voltage is decreased, so we can decrease the speed. And this is our aim now, is to control the speed. So if we want to decrease our speed, we can decrease the voltage using this average voltage. And here, as the power is a constant value and it's equal the voltage times the current, so when the voltage decreases, so we will find that the current will be increased. And when the current is increased, so we will find that the torque have been increased. So we can conclude that by controlling the current, we can control the torque, and by controlling the voltage, we can control the speed. So the speed is related to the voltage and the current is related to the torque. So this is how can we control the speed of our DC motors. So it was our lecture today. Thank you for watching and see you next lectures.